Hello everyone. Welcome to the episode 14th in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. Today's topic is an extension of multi-threading to multi-braiding, the so-called adjoint threading, and adjoint threads. After a brief theory, I show some practical examples and provide links for further study. Consider software log trace message stream. Most tracing implementations include thread ID in the output. So from software tracing perspective, a thread is an ordered sequence of messages with a specific thread ID. So if we filter the trace output, we get a uniform trace message stream which we can analyze for temporal and structural patterns of software behavior. Here I also introduce a bracket notation where bra denotes a constant attribute and cat denotes a variable message attributes such as CPU, action, module, file name, or function. On the next slide, you would see why I introduce this notation. Because of the primacy of threads, we do not always pay attention that from message stream perspective we can select other attributes. Suppose we are interested in messages arising from code executing create process or create file functions. Then we have a different message stream where thread IDs are variable. Here too, we can analyze message stream for the same patterns such as discontinuity, time delta, anchor messages, and so on. So we proposed a name, adjoint threads, and borrowed the name adjoint from mathematics. When you get this presentation, you can go through a Wikipedia link about adjoints, or you can search. So basically what adjoint is, when you have this structure or similar structure, then in mathematics this is usually described by adjoint terminology in various mathematical branches. So for threads of activity we have constant thread ID and variable attributes, but when we do the other way around, so we have some other attribute as constant and therefore thread IDs are variable, then we have an adjoint thread. So what I do now, I show you in process monitor. For example, there was some trace already recorded some time ago, and what we do, first of all we select columns because, for example, thread ID is not by default. So we see the thread ID added. This is this one, thread ID, and what we also have process ID, process name, process ID, then some action. And if you have custom tracing, you might also have function name columns, file name column, and so on. So what we do here, for example, if we are interested in all messages where process name is SVC host, and these can be different process IDs. So what we do, we filter by process name is SVC host, and then we add, for example, function name of here. This is operation. Let's say let it be create file. So we get less messages, some message stream, adjoint thread that all involve process name and the same operation. Some people also use Excel for analysis of application logs. We can do exactly the same. This is the same log, PML log, saved in CSV file format, comma separated values. We can use either filter menu or use right click and then filter, for example, by SVC host, this cell value. And then if we search for say create process, if you try to find create file, for example, and then if you filter SVC host or SVC host for this cell value, we get similar, actually the same output, the same adjoint thread. So I put these examples on the slide. So you see that you can do complex adjoint threading, create whatever adjoint threads you need. And when you get this thread stream, adjoint thread stream, you can apply the same patterns, temporal, like discontinuity or time delta, or search for some sequence of important messages, the so-called anchor messages. And also don't forget that you also have fiber bundles. This I call when every message has another associated message stream, for example, a stack trace, but it can also be another stack trace. For example, IO request IRP, IO request, packet, stack trace, and so on. So whatever you have some kind of orthogonal, I would say metaphorical orthogonal traces to any given trace message, we call this pattern as fiber bundle. And so I put at the end, I put here some articles that explain joint threading. So it is, I believe that this is a more useful concept than just selecting messages based on attribute and consider them as just a set or collection. And regarding Citrix CDFAnalyzer, you can, I put a link to the article, and basically the article shows the same filtering. For example, you can create from message stream, you can create an adjoint thread which has only info, some kind of information level adjoint thread, or it can be any adjoint thread that has specific message and so on. So you all get this presentation later. I uploaded it to Debugging TV. And finally, now some ads as usual. In November, there's a software trace analysis training that covers more than 50 trace analysis patterns. It's called Accelerated Windows Software Trace Analysis. And we also plan the old new debugging training. It's the new old debugging training. It's the other way around. The new old debugging training, where you acquire skills and mindset of a seasoned professional debugger. For example, you learn Windows debugging from its historical roots and beginnings, starting from BIOS, DOS, Windows 3.x, assembly language, and so on. So that we hope to do this training and also remind ourselves some basics. So thank you for watching this episode. Please later check out slides and recorded video from Debugging.TV. The next episode should be on 22nd of October, hopefully. After numerous requests, we started adding Debugging TV episodes to YouTube. Now there is the previous one episode, the previous 13th episode is there, so we hope to add more episodes, including this one. So thank you for attending and see you next week. Bye-bye.